Great. So, hello, welcome. Welcome to Talking Data Equity for Friday, July 21st. My name is Heather Kraus, and I'm coming to you back in the office in Toronto. Yay. And I'm the founder and chief data scientist for an organization called We All Count. And We All Count is a project that focuses on embedding equity in quantitative research and evidence. And we do talking data equity pretty much every Friday, not every single Friday, but most Fridays at this time. And the purpose of talking data equity, if this is your first time joining us, we are very excited to have you join us. Purpose of talking data equity is to get together informally so that anybody in any sector, in any country that's trying to figure out how can I bring more equity to the data work that I'm doing? How can I align the way that I'm using data, the way that I'm generating evidence with the lived experiences and communities that I'm trying to center? So that anybody working on that can get together and share ideas that are working for them, share challenges they're facing, share resources. And sometimes, lots of times, we have special guests, and we have a lineup of fantastic special guests starting next week with Dr. LaShawn Richburg Hayes, who is an expert on equity in educational effectiveness research. And sometimes we talk about topics because we have an open type form where you folks can tell us topics that you want to discuss at Talking Data Equity. And that is what we are doing today. Today, we're going to talk about the topic of statistical weighting. And lots of you have asked about that. And the last bit of housekeeping I'm going to do is to let you know that we run this Talking Data Equity session as a Zoom meeting. And we're going to try and do that as long as possible because we think it's really, really nice to have a space where you can feel and see that you are not alone in any way, that there are lots of people that are thinking about the same things as you and working on the same things as you. And because of that, we are going to make use of the Zoom chat for the first part of this meeting today. So I'm going to share a couple of examples just so to kind of level set about what statistical weighting is and why it's an equity issue. And during that time, feel free to use the Zoom chat as much as you would like. And you can use the Zoom chat either with that Zoom chat drop-down menu set to everyone, which means that everybody in the meeting will see your comment. Or if you'd like to participate privately, you can just use my name and you can send me a direct message with a comment or a question. And so we're going to ask that you use the Zoom chat for like the first little while I'm sharing a couple of slides. Then I'm going to stop sharing my slides, and you can raise your hand and unmute and ask your questions or share your experiences or contribute your own ideas and wisdom. Okay, so that's what we ask in terms of logistics. And so I'm going to share a couple of slides here. So we're going to cover a couple of different topics because not a couple of different topics, but a couple of different we're going to look at statistical weighting in a couple of different ways because we have people here who are just getting started at quantitative work, and we have people who are very advanced and have been doing, very technical statistical analysis for a long time. So we want to do a little bit of level setting to get as many people as possible kind of into the flow of things, and then we can have a conversation. So what even is statistical weighting? Let's say that you have a community of people that you would like to understand. And what you really want to understand about this community of people is their opinions. In fact, you have a space in your city and you're trying to find out, would your residents like you to build a dog park, or would they like you to build a pool? And you're pretty sure that everybody in your community has an opinion or a preference between dog park or a pool. And you'd like to collect some data in order to do that. So the intended population, who you're trying to understand, are all the residents in your city. However, you don't have enough time and money to do a survey that captures the opinion of everybody that lives in your city. So instead, you do a survey that captures a smaller chunk of all the people in your city. And we call that the sample. Now, I've used the words here on this slide, the actual sample, and we're going to talk a little bit about that in a minute, why I'm saying actual sample. But essentially, bottom line is there's a larger group of people that you are trying to understand, and you have data about a subgroup of that larger group. And sometimes there's lots and lots of different technical terms that can be used in weighting, depending on what country you're in, what discipline you're in, what sector. But oftentimes that big group is called the population and the small group is called the sample. Not always, but often. Okay, so this is the situation that we find ourselves in. How are we going to take the data that we have from our actual sample, the opinions about, do you want a dog park or do you want a pool, and make a decision that hopefully will come close to representing the preferences of the entire community? That's where weighting comes in. We want to take what we know from this small sample and try and get it to reflect the desires of our whole population. Okay, so in general, now we have only an hour together, and I want to leave as much time as possible for your questions. So I'm not going to go into the nitty gritty of every possible thing about weighting, but in general, you cannot just take the sample data that you have and maybe count up the number of people that want a pool and count up the number of people that want a dog park and think that that's going to accurately represent everybody. Most of the time, you cannot do that, even if you have spent a lot of money and done a lot of fancy like randomization and stratification and advanced ways of figuring out who you're going to include in this sample. Even if you've done that, it's usually not this equals this. And that is where we get into this thing called weighting. That is why there is this thing called weighting. The thing called weighting, when it comes to survey analysis, is designed to help you get closer to feeling like the opinion you have from this sample is useful in helping you understand what this intended larger population actually feels. And let's say that our intended population, the big community that we want to understand, that we want to give either a dog park to or a pool to based on what they want. Let's pretend that that is made up of 50% green and 50% purple. And our sample is made up of 25% green and 75% purple. And let's pretend that whether you're green or purple probably has a relationship to whether your preference is for a pool or a dog park. What weighting does is it takes the actual sample that you have, it does some manipulation to it, and it gives you some weighted results. So it takes the actual sample, and in this case, it pays attention to how many green dots you have and how many purple dots you have. And it tries to kind of smooth them out and arrange them in a way so that the proportion of green and purple dots in your weighted results are close to, if not the same as the proportion of green and purple dots in the group of people that you're trying to understand. Okay. Basically, we're just going to stay at a pretty high level here, but basically, if this was our situation and we had in our sample a small number of green and a big number of purple, where our community, our intended population is 50-50, what weighting is going to do is it's going to take the results from our green dots and it's going to make them heavier. It's going to make them bigger. That's why it's called weighting. It's going to take the information that we have too little of, right? We have too small of an amount of green information because we need 50% green information. We have only 25% green information. So it's going to make the green information way more. It's going to make it heavier. It's going to make that dot count for more. And it's going to make these purple dots a little bit lighter, count for less, because we have too many purple dots in our sample. So that is essentially, bottom line, broad strokes, what weighting is designed to do. And I want to show you a little snapshot because I know sometimes if you download data from like a government health website, that data is going to come attached to with a variable, and that variable is going to be called the weight. And essentially that variable that's called weight has been calculated. There are more than one way to calculate a variable's weight, depending on exactly how you want to use it. But essentially, all the ways follow a basic concept, which is we're going to take how many people are in our intended population. We're going to compare that to how many of those types of people are in our actual sample, and we're going to make their results heavier or lighter. That's why they're called weights. So let's pretend instead of whether somebody is green or purple, we care about how old someone is, which age group they fall into. You can see that this is the share of each age group in our intended population. So 24% of our population is ages 18 to 34. But in our sample, the people who answered our survey, 28% are between the ages of 18 and 34. So that means we have a few too many people in our sample relative to the population we're trying to understand. So we're going to make it a little bit lighter. So if the weight is 1, that means there's no change. We're not making it heavier. We're not making it lighter. And so 0.85 means we're making it a little bit lighter. Okay. All right. So let's look at one more part of our dog park and pool example. Let's pretend that we are collecting data on whether you want a dog park or a pool, and then we're collecting 3 types of demographic data: whether or not that person is Hispanic, what gender that person is, and how old that person is. I want to show you this example because lots of times, if you're trying to make a survey sample fit or give you a good answer to what your whole city wants in terms of a dog park or a pool, you might want to weight by more than one thing. First thing I showed you was just looking at green versus purple. But let's say that we want to make sure that our results are representative of our city along 3 dimensions. We want to make sure that whether or not a person is Hispanic, what gender a person is, and how old a person is are all taken into account when we make their results heavier or lighter, when we decide how we're going to weight their opinion. So this is, of course, a tiny snapshot. We would have more than 5 people. But I wanted you to see something that looks real. Like if you downloaded this data, this is what it might look like. It might give you the person's ID, give you what that person's Hispanic or not Hispanic, tell you whether they checked the box that says female, check the box that says male, check the box that says non-binary, tell you what age they checked, and then whether they wanted a pool or a dog park. And then when you download this data, it might also come with a weight. Or if it doesn't come with a weight, you might want to calculate this weight. And if you're going to calculate it using 3 demographics at the same time, you're going to need to do a little bit more advanced analysis, but almost any data analysis tool that you use will already have kind of a recipe for you to calculate the weight. It's usually called rake weighting, R-A-K-E, rake weighting is probably the one that you might want to start with. And Excel can do it, R can do it, SPSS can do it, Stata can do it, Qualtrics can do it. Most of the tools we talked about last week can calculate this weight for you. So what does this weight mean? If this person has a weight of 3, and this person has a weight of 0.5, and this person has a weight of 1, what does that mean? This is what that means. It means that when you're going to decide, do we want this, does our city as a whole want a dog park or a pool? Well, when we use weighted data, if something has a weight that's above 1, we're going to count their answers more than once. So this person has a weight of 3. So their answer is going to get counted 3 times. And this person has a weight of 0.5. So their vote is going to get counted half of a time. And this person has a weight of 4. So their vote for dog park is going to get counted 4 times. And this person has a weight of 1. So their vote for dog park is going to get counted 1 time. And this person has a vote for pool and a weight of 0.5. They are going to get counted half a time. So every single method, there's 3 or 4 different ways of calculating weights. And then there's a couple of choices about what to do with weights. So they each vary slightly from this, but they all share this basic concept, is that if somebody has a high weight, what that means is they're underrepresented in the survey. So there aren't as many Hispanic female 25-year-olds in our survey. Actually, yeah, there aren't as many Hispanic female 25-year-olds in our survey as there are in our city. So we're going to count this vote 3 times. But when we look at non-Hispanic females who are 58, there are actually too many in our survey compared to how many there are in our city. So we're going to make that vote a little bit lighter. So bottom line, that is what weighting does. Like I said, there are different methods, there are different exact ways to calculate these, but this is the theory and the concept that they all basically share. And this is why we would bother doing it. So that is what is statistical weighting. Second thing I want to mention so we can have a conversation is, what are the layers of statistical weighting? In other words, why did I use this word actual sample? Because this is where it can get really, really confusing. I'm going to just back up a couple of slides. I really simplified things in this picture: actual sample, intended population. Because of course, to calculate the weights, you're going to have to pay attention to how somebody got into your actual sample. And you're going to have to figure out, what is my intended population? And neither of those things are easy. Both of those things are very subjective, as we've talked about lots of times. And so you're going to have to pay attention to 4 different groups of people if you want to either use weights or consume some kind of research that's been done with weights. And the easiest group of people to identify are the people that ended up in your data set. It's usually a survey when we're talking about weights, but it's not always a survey. The people who ended up in your data set, they're pretty easy to identify because they are there. You have their data. But that group of people came from a larger group of people who were exposed to your survey. And so to the best of your ability, you're going to want to try and identify and keep track of that. That's why sometimes if you're like a social sector agency and you're trying to collect demographic data, we ask you to write down even when you ask somebody to complete your intake survey and they don't. This is, oh, how the heck did I do that? Oh dear. But this is why we bother telling you, write down when somebody says no to your survey, because you want to know more about the group of people that are exposed to your survey. Third is the group of people who could possibly be in your survey. Now, here's where we get a little bit, this is where it gets really philosophical. This is very theoretical. There's a theoretical population in your city. Of course, every city has people moving in and moving out and interested in taking a survey. So we want to think carefully about who that group of people is. And then finally, the biggest group is, who are we trying to understand? Are we trying to understand the residents of your city? Are we trying to understand the full-time residents of the city, the year-round residents of the city? I'm thinking about this because in New Jersey, of course, where I was last week at the Jersey Shore, who's in that county in January is very different than who's in that county in July. I used to live in a really small town in Northern Ontario, and who was in that city again in January was very different than people who officially lived in that city. Lots of people officially lived in that city, but we're only there for a few weeks when it was actually warm. And I'm not going to go into this, but I wanted this to be on the slides so that you could have access to it if you came back and looked at it later. But things to think about and to try and take account of when you're moving between these two circles is non-coverage error. So non-coverage error is when people that we want to understand somehow don't make it into the group of people who could be in the survey. An example of that is sometimes people who work for the military. They may be in your city officially, and maybe you really do want to understand, do they want a dog park or do they want a pool? But if you don't remember to include people who work in the military in your group of people who could be in your survey, you're going to have non-coverage error. Sampling error and hard to reach populations are about who could be in your city and who gets exposed to the survey. So if I'm trying to make sure that I capture everybody that's in the city, but I forget to send one whole neighborhood a link to take the survey, then I've created sampling error. A whole neighborhood is missing. And that is shockingly common. It's very, very easy to do. And then hard to reach populations might be people who don't have a fixed address. And if I'm only, or don't have a landline, if I'm only going to call people who have a landline and say, do you want a pool or do you want a dog park? That might be a hard to reach population. I'm showing my age there because of course, nobody has a landline anymore. That's how it used to be back when I used to do phone surveys. Okay. Unit non-response. Unit non-response is like the technical jargony word for you ask somebody to complete your survey and they say no. That's unit. They were like, nope, no to the whole unit. Item non-response is jargon for I didn't answer one question on your survey. I took part of your survey, but I didn't actually answer the question about did I want a dog park or a pool because I don't really care. And so you need to figure out a way to account for that because it's very different if I'm trying to do a survey and somebody says, I'm not going to answer your survey at all. We now have no information about that person, and figuring out how to wait for them is going to be pretty hard, but we can do it to a certain extent. if they've answered some of my questions, like maybe I know that they're a Hispanic female who's 30 years old, but I just know that they didn't tell me if they wanted a dog park or a pool, that's much easier for me to adjust with weighting. Underreporting and top coding are basically things that happen when you're cleaning the data. Be very careful, essentially, if you're removing people from your data while you're cleaning it. Okay. Last thing I'm going to show you that's really technical, and then we're going to look at an equity issue about this. Then I am going to open it up for questions. What does weighting actually change? So when I am trying to weight some data, it's going to change two things. And we've used these words before here in Talking Data Equity, but they can be a little bit jargony. Weighting is going to change the point estimate, and it's going to change the standard error. So the point estimate is the number. So if I'm trying to get the average age, and I calculate that the average age is 5, that's a point estimate. It's the average. It's usually the number everybody wants to know. Not always, but usually. So the point estimate is what most people think of as the result or the outcome. The standard error, again, we're not going to go into the whole math of the standard error, but the standard error is the variation around that average. So you can see that we have a bunch of different ages. When we asked people in our community, we collected age in addition to Hispanic and non-Hispanic and gender, and we asked them how old they were. Obviously, these are not the real ages. I just wanted to show you an example. 2 years old, 3 years old, 4 years old, 5 years old, 6, 7, and 8. And we want to know, what's the average age of our respondents? Well, the average age of our respondents is 5, but there's variation around that. So it's really 5 plus or minus a year or 2. And weighting is going to change both of those things. Weighting is going to change what the average is, and it's usually going to make the variation wider. Because if you remember, some people's results now get counted 3 times or 4 times or 5 times. And some people's results are going to get reduced. They're going to get made lighter half a time or a quarter of a time. So what that's going to do is that's going to increase the numbers that are spread out. It's going to increase the spread around the average. So when you weight your survey data, you're going to get a different point estimate. The average age is going to change, and the plus or minus around the age is going to change. Usually in weighting, not always, but often, the plus or minus is going to get a little bit bigger. Okay. I'm going to skip that for time because I don't want to run out of time. So how is this an equity issue? All right, you already can absolutely see how this is an equity issue because you're a very smart group of people. This is an equity issue because there are so many subjective choices that are getting made here, right? The first subjective choice that is getting made is obviously, what are you going to weight by? Are you going to weight by race? Are you going to weight by age? Does it matter? And that is going to change things. It's not always going to change things that much, but it will change things. But the second thing that can really change things a lot is if we decide, for example, that we want to weight by race and ethnicity, and the data that we have on race and ethnicity isn't that great, that is going to really change the totals. So I wanted to just briefly give you a mention of this example, and we'll make sure that we link this in our forum so you can read the whole thing if you're interested. But this is a really good study about the effects of how people were sorted into races and what a large effect it has, especially for people who belong to races that are going to have very sensitive small sample sizes. They used in this example people who are American Indian and Alaskan Natives. And they walk you through 3 different ways to weight this information based on slightly different classifications of how people are sorted into boxes of American Indian and Alaska Native or not. And I'm just going to, again, you can read this whole paper if you want, but I'm going to make the point that how they chose to collect this data and how they chose to weight this data in estimating something, you know, fairly straightforward, like does somebody have asthma or not? The percent of people in this state that have asthma really change. So we go from 19.5 to 15.2 to 17.8. That's a really big difference. And that's not a difference that's changing over time or changing in response to any kind of initiative. That's a difference that's changing in response to how race data is being collected and how race data is being thought of when it is weighted. So what we decide to weight by makes a big difference. How we collected the data that we're using, whether it's race data or gender data or anything else that has a better or worse fit for different people, that's going to actually change the outcomes. Another issue is that if you're trying to decide, if you're in the business of trying to decide if something worked, you're trying to get like average treatment effects. The way that you use weights, and this is a more sophisticated use of weights, you're going to put them into regressions, you're going to put them into ANOVAs and things like that when you're doing causal analysis. But the way that you do that can often mean that whether or not something quote unquote works for your sample is very different than whether or not something quote unquote works for the population that you're trying to understand. And that's a huge equity issue, because whether or not something is shown to work by using this type of analysis often determines whether or not it gets to be used in a school, or whether or not a government's going to adopt that policy, or whether or not that some foundation is going to fund it. And if there's a difference that, and they make a very, very good point here in this article about how it is a researcher, I can't find it in this thing, but it's a researcher. Oh, here it is. Researcher degree of freedom. That's a very, very nice way of saying this is totally subjective. And it is. Okay, last thing I'm going to show you, because there's lots going on in the chat and I want to make sure that you have plenty of time, is I'm going to show you one last example of how weighting affected what we thought was happening in the early days of the coronavirus. And this is in the United States. And again, I'll link to this article as well. But this is a group of people who are using who are looking at the data that the CDC is putting out, and they're trying to understand how weighting is affecting the level of disparity that's being reported about, are more Hispanic people getting sick, or more Black people getting sick? What's the relative disease and death burden of COVID? One of the things I want to say is that this data that I'm showing you is from the very, very early days of the coronavirus pandemic. This data is not current. This data, of course, if you remember, like March and April of 2020, like that data was messy, and we were just trying to do the best we could. So this does not represent our best understanding of what happened right now, but this does represent our best understanding at the time of what was going on. So please don't quote these numbers as what is happening now. But rather, I'm showing this to you so you can see what happened then in terms of the process of weighting and what a big difference it makes. Bottom line is that this group of researchers was trying to understand the relative burden of COVID. And I just want you to look at these two columns. This column is the percent difference for that race when the data is weighted. And this column here is the percent difference for that race when the data is not weighted. And in this instance, you can see, so 4.2, this row is Black, people who are Black. This 4.2 means that there are 4.2% more people who are Black dying of COVID than the share of people who are Black in the whole population. So there's a greater burden on people who are Black. Unweighted, though, it's basically almost 10%. So it's much, much higher. And for people who are white, it's reversed. The weighted estimate was close to 11%, which is very high. And the unweighted is negative 8%. So the point here, we're not going to get into a big discussion of whether these specific numbers are accurate. We already know that these specific numbers are not accurate. It was like April of 2020. Data was insane. But the weighting is still what we're trying to understand here, is that if we decide to weight something and how we decide to weight something can A, change things very, very much. B, has a real impact on what we think of as happening in disparities. And C, here's the really important part that these authors try and make, is that one of the ways that this particular data was weighted, and you can read the articles on your own if you're interested, was geographically. And what weighting geographically did was that it put really unusual weights on the urban areas where there was lots of overcrowding and where there were many, many more Black people living at that time. And even though they were trying to do this weighting in order to get like a quote unquote fair, quote unquote objective idea about the disparity, the way that they weighted it actually ended up probably doubling down on disparity, because the way that they weighted it at the time was they used geographical clustering as like a quote unquote nuisance parameter, as a thing that they just wanted to like smooth away with weighting to get an accurate distribution. But that geographical clustering was actually the source of the racial disparity, of driving a lot of what was going on around disparities in COVID. And so to wait for it to smooth it out hid the problems with inequities. And I don't say hid like I think somebody did this on purpose. But I do think that right now across the board, lots and lots of weighting decisions are made out of assumptions that, you know, if you're using health data, you should always weight it by age, sex, race, geography. And that is not a good thing that we don't take the time to pause and think through, okay, why would we weight that? What are the pros and cons of weighting that? And what's that going to do to the outcomes that we're looking at? So again, this was a very, very hard time, and I don't think anybody was intentionally trying to do anything nefarious, but it still demonstrates that, intention aside, anytime we're making a choice of how to combine data, it is never objective. You cannot actually produce an objectively weighted outcome. If you are going to apply weights to a data set, you are going to be changing, distorting, adding some opinions about what is relevant and what is important to that data set. And lots of times that's a correct decision and you should do that. But never under the false myth that doing so is going to produce something objective. The last thing I'm going to say is that if you really want to think about it, if there is a disparity in COVID rates between, say, Black people and white people, and we have that disparity rate for every, let's just say every county in a state, and we want to roll that up and get a disparity rate, a COVID racial disparity rate for that whole state, we're going to have to make some weighting decisions, right? We're going to have to figure out how we're going to combine that county data. And one of the options is to weight each disparity by just the number of people in that county. That's one possibility. Another possibility, though, is to weight that disparity by the proportion of Black people in that county. And the difference between those two choices is the difference in whose lived experience is going to get embedded in those results. If we're trying to weight county level racial disparities and we weight them by the proportion of Black people in that county, we are going to get a result that really accurately reflects the lived experience of Black people in your state. If you decide instead to weight by the entire population and your state has, a majority of white people in the state, you're really going to be getting a result that reflects the lived experience of the majority white people in your state. So again, one of those is not the only thing that you should ever do. There can't be a rule about this, but there can definitely be some suggestions. So here's the suggestions, then I'm going to be quiet and you folks can take it. Number one, it is essential that if we're going to weight anything, we explicitly say why we're weighting them. What is the value and the value to who by making some of these results heavier or lighter? And sometimes it is really essential for you to get an equitable piece of research that you use weights. I don't want you to leave here thinking, oh, weights are always wrong. Sometimes weights are really essential. Weights are often essential if you're trying to understand hard to reach populations or small populations. Weights are important, but we need to say why we're using them. Two, we need to say what choices we made. What did we decide to weight by? Why do we think that the things that we're weighting by are relevant? And when I say by, I mean like in our dog park example, we weighted by Hispanic, gender, and age. And none of that is a mathematical inevitability. There is no science rule that says if you have health data, you have to weight it by sex, age, and race. That is not a scientific law. That is a habit that has been deeply ingrained over time and definitely should be examined. And this came from Mish. I really want to give a shout out to Mish, who really emphasized when I was thinking through this, who made the choice is also really important. When reporting results that are weighted, it's also really important to make the unweighted results easily accessible. Not like you have to send 5 emails and jump through a few hoops, but maybe in that same report, the unweighted results. So you can see, okay, what these choices did to the results. And then sometimes, depending on the nature of the research that you're doing, it might be a good idea to just document and decide in advance whether or not you're going to weight and how, so that you're not tempted to make those decisions based on outcomes. Okay, you've heard enough from me. Let's see what's going on in the chat. Let's see. Now, this is the time when anybody who is here and wants to raise their hand and ask a question or share an experience or share their wisdom, we would love to hear from you. And while you folks decide to raise your hand, I'm going to go through the questions in the chat. Oh, great. Some people are adding great examples. Hey, Allison, go ahead. Thank you.
Hi, sorry, I'm in a noisy coffee shop. Thank you so much for this presentation. I just wanted to lift up my question that's in the chat early on, but I am wondering if you have any thoughts or resources about whether estimates on subpopulations are valid when the weighting scheme is not weighted according to some variable that you are creating the subpopulation for. So, you know, when national surveys weight based on race, usually a group like Native American is not one of the populations that they use to create their weights, or income or education level, but like we often, like I see all the time estimates that are crossed by those variables. So I'm wondering if you recommend making your own weights, or just any thoughts or resources about whether those estimates are valid when the weights are not created with those parameters.
Allison, that is a great question. And I highly recommend the article that I showed 1 or 2 slides on, about different ways to weight American Indian and Alaskan Native data that have been collected in different ways, because they've actually developed their own methodology that they recommend, that they think works really well, that corrects the exact problem that you're talking about. That often those populations aren't included in the weighting, and that is, I mean, it's not usually a good thing, and it's a problem for strategic resources, and it's a problem for doubling down on the racism and colonialism that's created the problem to begin with. So my first thing would be to point you in the direction of that article, which we will be sharing on our community forum. And the second thing I would say is that it very much depends on the question that you're trying to answer. So there's a big difference between using weights to understand what's happening with a specific subpopulation. That's very different than using weights to try and get an accurate representation of the whole population. So if we just stick with the dog park example, there's a big difference between trying to understand if the American Indian people in your city would prefer a dog park or a pool, versus making sure that the American Indian community's voice is included in that average population, in terms of, does your whole city want a dog park or a pool? And for the second one, when you're trying to make sure that that voice is included, I would strongly encourage you to either calculate your own weights, find somebody who's an expert in weighting to help you calculate the weights, because that will help that situation. If what you're trying to do is just understand that population, weights can be helpful or weights can be distorting, depending on how that person came into your sample. That's where we would go a little bit into that methodology of like those concentric circles. How did people get into your sample? And the method that they got into your sample would lead me to either want to weight that or not, if I'm trying to understand that in specific. That makes sense? You don't have to unmute. I know you're in a coffee shop. Okay, great. Okay, I'm going to keep going through the chat, and absolutely want to raise up a couple of comments that are like, systemic racism, white supremacy means we do not have to be intentional to end up with racist conclusions. 100%. If you are working with data, it's not good enough to be like, I didn't mean to do that. And that's a deep-seated problem with this myth of objectivity around quantitative analysis. So I strongly agree with you that doing racist research by accident is no excuse. Okay. I am still trying to wrap my head around what it would mean to weight for the Black population in each county. A couple of people have asked about that. And somebody else, I'm going to kind of answer these two questions at the same time. Someone else has said, weighting is as much art as it is science. I think that is true for all quantitative analysis. It's as much art as it is science. That said, the benchmarks or targets that are used to weight should be externally validated, not simply one's subjective assumption about the composition of the intended target population. That's a very interesting comment. And so I think if I understand this person correctly, they're saying, when we decide how to craft a weight, we're going to use a numerator and a denominator. One of those is going to be, say, the number of Black people in your sample, and one of those is going to be the number of Black people in your population. And this person is saying the number of Black people in your population needs to be an actually validated number, not like your gut sense. And I would say that it definitely needs to be transparent. It can't always be a perfectly validated number because, for example, if we're talking about the transgender community, if we don't wait for the transgender community until we have an exactly accurate count of how many people are in the transgender community in my city, I will never wait because it's very, very hard to get a perfectly valid count. And it's a dynamic situation, as most are. So I would say for sure you need to be transparent about what you used for the numerator and what you used for the denominator, and use something that is valid according to the purpose and intentions of your research. But it's very important. Like the choice of that numerator and denominator is extremely important. I was wondering if there's ever a use for applying different weights to the same data depending on the question you are looking for. Obviously, that can get cumbersome and practically difficult. Yes, for sure. I didn't go into it for the purposes of today, but there are many different ways to do weighting. There's lots of different kind of mathematical procedures. And some mathematical procedures will be very important if you're trying to get that population estimate, like should we get a dog park or should we get a pool? And then a different set of weights will be more useful if you're trying to predict what you should do in 3 years. If you're trying to like build some kind of logistic regression model, you're going to want to use different weights. So yes. I never see this option when analyzing national data sets. Okay, that's a really important thing. Thank you for saying that. And if you have time, please ask that question or put that into the data equity forum, which is free. It's not a membership site, because I don't know what country you're in, so I don't know what national means for you. But for the European Union, Canada, and the United States, most of the kind of online analyze like the census yourself kind of websites that are built by the government do have boxes where you can check whether or not you want something weighted. And usually you can check if you want something weighted for non-response by the individual or by the household. So if you remind me and put that in, I will ask somebody on my team to add some screenshots that show you how to do that, because that is a very, very important question. All right. Somebody, will you help me share this potentially useful article in the chat? Okay, I'll see. We are going to share all of the articles that we've talked about on the forum. And here's another article that somebody wants us to share. I haven't read this article, so this article may or may not be a good idea. Let's see. Many surveys allow for non-answers to demographic questions. Do non-answers get excluded from a weighting analysis? Okay, we're going to end on this question because I know it's almost the top of the hour, because that's a very, very good practical question. And that is a question that you want to ask if you're using somebody else's weighted data. And if you're doing it yourself, usually if you have a lot of non-answers to demographic questions, you're going to want to do one round of weighting that kind of corrects for non-response to the demographic questions. In other words, corrects for missing data. And then you're going to want to do another round of weighting that adjusts the demographic characteristics for your item of interest. So for the dog park or the pool, if you have a lot of missing data. If you have a little bit of missing data, on a really practical level, it usually just gets dropped and not included. We should do another Talking Data Equity on missing data because that is a whole other question. Okay, top of the hour, we have to go. I know we haven't answered all your questions. Feel free to put your questions into the Data Equity Forum, and we will get you answers and resources. And next week, same Zoom link, same time, Dr. LaShawn Richburg Hayes, amazing researcher, done some extremely useful and groundbreaking work on equity in educational effectiveness research. And it is going to be a real treat. So highly recommend that you join us next Friday, or that you watch the recording if you can't. It is so nice to be back with you all, and I missed you. So thanks for rejoining, and take really, really good care of yourselves and really, really good care of each other. And remember that you are not alone, and we're in this together. See you later. Bye, everybody.